final thing I want to say here about the center of mass is to explain something that's kind of a tough problem for students. It's one of the homework problems. And so imagine, it'll be similar to one of your homework problems. Imagine you got a farmer and has a big barrel here. Okay, where's the center of mass of the barrel? Okay, if the barrel is some height h, then the barrel has some mass m sub b. The center of mass, the y center mass of the barrel is going to be h over 2. Okay, makes sense. So now your barrel here is filled with water. Where's the center of mass? Still h over 2. No big deal there. Now your barrel is got water in it. It's got some area A. It's got water in it, and the water only fills the bottom half of it. So where's the center of mass? Well, now the center of mass is a little more complicated. So we have to figure this out. Y center of mass is going to be equal to the this is now filled up, some height h over 2. And so the y, the center of mass, is going to be, well, it's kind of like we did with the previous problem, mass of the barrel times the h over 2, the center of mass position, plus the mass of the water times h over 4, because it's about half of that, divided by the mass of the barrel plus the mass of the water. So the y position, the center of mass, is now going to be the mass of the barrel h plus mass of the water h over 2, okay, divided by 2 mb plus mw. Now you can work that out, and that turns out it's going to be lower than it was before, okay, because now you have more mass towards the bottom. Okay, but wait a minute. If the barrel is totally full, center of mass is h over 2. Okay, if the barrel is totally empty, center of mass is h over 2. But if the barrel is partially full, the center of mass is below the center line. Okay, so what does that mean? Well, that means at some point there must be a minimum. So what is the minimum height of the center of mass? How would you figure that out? Well, so we got the barrel. Okay, if we got water in it, we'll say the height of the water is going to be some x. Okay, so that means that the YCM, okay, is going to be equal to mass of the barrel h over 2, because we'll say this is some height h, okay, plus mass of the water x over 2, divided by mass of the barrel plus mass of the water. Now, what is the mass of the water? Mass of the water is going to be the density of the water times the volume of the water. What's the volume of the water? It's going to be the area times the height of the water column, so rho AX. So that means that YCM is going to be mass of the barrel h over 2 plus rho AX times x over 2 divided by mass of the barrel plus rho AX. So we can write that a little bit neater. So that's going to be equal to mass of the barrel h over 2 plus rho a x squared over 2 divided by mass of the barrel plus rho a x. Okay. Well, I can actually factor out the 1/2. So this is 1/2 of mass of the barrel h plus rho a x squared divided by mass of the barrel plus rho ax. Now, I want to find when's that a minimum. How do you find the minimum of a function? Well, what you do is you take the derivative with respect to x and set that equal to 0. So that means you have to take the derivative of 1/2 mbh plus rho a x squared divided by mp plus rho a x and set that equal to 0. Now, I can divide out the 1/2. And so that means that really all we have to worry about is setting equal to 0 of mbh plus rho a x squared divided by mb plus rho a x. So I got to take the derivative of that. How do I take the derivative? Well, it's the quotient rule. So for the quotient rule, then what we do is we just take the derivative here. Okay. So it'll be the bottom times the derivative of the top. Okay, so mb plus rho ax times the derivative of the top is going to be 2 rho ax. Okay, minus the top, mbh plus rho ax squared times the derivative of the bottom, rho a, divided by the bottom squared. So mb plus rho ax squared. Now, if that's equal to 0, that means the numerator is equal to 0. So we could actually make that a little more complicated, a little bit easier, and just say that mb plus rho ax times 2 rho ax minus mbh plus rho ax squared times rho a equals 0. All it has to be is the numerator 0. We can divide through by the rows, divide through by a's, multiply through that 2x over here. So that's 2mbx plus 2 rho ax squared minus mbh plus rho ax squared equals 0. Okay. Sorry, it's minus rho ax squared. So we have a 2 rho ax squared minus rho ax squared. So that means we have rho ax squared plus 2 mbx minus mbh equals 0. Okay. All right. So all we have to do is we have to use the quadratic formula. So minus 2mb plus or minus the square root of 4mb squared, okay, plus 4mbh rho a divided by 2 rho a. Okay. All right. So what we want to do, so rather, sorry, x equals that. Okay. So you look at that, we can actually factor out that 4 and those 2's all cancel each other. And so what we have is we have that minus mb plus or minus the square root of mb squared plus mbh rho a divided by rho a equals x. Now, we know that x can't be negative, so there's not going to be negative. So in order for it to be positive, we have minus mb plus square root of mb squared plus mbh rho a divided by rho a. That is your x. So the minimum height depends on the mass of the barrel the density of the water, the height of the barrel, and then the cross-sectional area of the barrel. So those are all the factors. If I gave you the numbers, you can plug the numbers in there and solve it, but this is how you do that. Now, that's a complicated problem. I'm not going to have you do anything like that on the test, but it's nice to know that this is possible, that you can do this. And again, upper division classes, you'll see more of this. But that's the last of what I wanted to say about Chapter 9.